Hello everyone, and welcome to another Salesforce Ben LinkedIn Live. Feels like a while since I've been hosting a LinkedIn Live. Had a lot of stuff going on in the summer, and some of my colleagues have been taken over. So it's very nice to be back with all of you, and thank you very much for joining us today. So we have a real treat today. We have none other than Andy Fawcett to talk through advanced concepts that all Salesforce developers should know. So if you're familiar with Financial Force, which is one of the biggest Salesforce ISVs out there, Andy used to be CTO there, so a lot of knowledge from the ISV world and Salesforce in general, and is currently working as a VP of product management at Salesforce. But what he is possibly most famous for is being the founder of declarative roll-up lookup summaries, which gives you the ability to create roll-ups not only on the master detail, but on a lookup, which is obviously a limitation of Salesforce. So let's bring Andy in.
Hey, thanks, Ben.
How's it going?
Very well, thanks. Good to be here.
Great, yeah. Thank you very much for joining us today, and also to celebrate the release of your latest book, which we'll find out about. So we'd love to hear where the audience is joining us from today, so feel free to write in the comments. I'll hand over to Andy now to take us through the presentation. If you have any questions, feel free to drop them in the comments, and if we have time at the end, we'll try and get through as many as we can. But this is a very popular session with a lot to cover, so we'll see how we go. But Andy, over to you.
Wow, thank you so much, Ben. And welcome, everyone. Thanks, first of all, for your time today. Time is precious. Both Ben and I also appreciate the fact that you're here, and hopefully get some good content and tips and tricks from this session. We're going to be talking about concepts both kind of in mind and in code. So stand by for some kind of reflective kind of discussion, as well as some code, of course, as well. So what we're going to do, a little bit of an introduction, a bit of background as to myself. And the way we're going to frame this is, what are the questions you should be asking yourself, that prompt thought and discussion among yourself in your own mind, as well as others, and kind of what are the answers to some of those questions and approaches that you might take in responding to those questions. So we're going to have a bit of a framing in that respect throughout this deck. And then we'll talk about my book. We've just got the 4th edition of that out, and really give you a sense of what it's about, if it's for you, what kind of content, if you've already got the book. This is the new 4th edition, and just take a little bit of a peek inside of that. And then if time, we'll close things out with questions. I'm also very happy to take questions in LinkedIn as well on the thread promoting this session. So without further ado, let's just have a little brief tour of Andy in the cloud. My journey began as a COBOL developer, actually, back in the day, building enterprise apps still. These were on all an array of platforms, including IBM. AS400 is kind of dating myself where I began, but really went into other languages and technologies, building client-server applications, the beginning of kind of separation of concerns. Financial Force was born in 2009, really taking some of those financial apps that had been developed on an array of on-premise servers, but then bringing them into the cloud. And Salesforce partnership was born there, with Financial Force being the first to really push Apex and technology like Visual Force. And like many technologists and technical people, I am literally a bit of an introvert normally, but when I like something that I'm excited about, a lot of those fears tend to go away and get excited about talking about tech. And Andy in the Cloud was born. Dreamforce presentations, an early book, began in 2014. And like many folks that get excited about things, I was delighted to find that the MVP community welcomed me in 2013. And 2017 saw me move to the US, where I am right now. I've been there since 2017, and started Salesforce just after that as a product manager. And delighted, because I'm a little bit of a Lego geek as well, to find that the building that I work in made out of Lego. It's a pretty cool moment when I heard Lego are doing that. See there in the bottom right corner, my wife Sarah and our little French bulldog Lilo. So a little whistle-stop tour of me. Some of the things that some of you might be aware back in the day when things began was cats. This was kind of fairly typical way I'd start a presentation about separation and concerns, asking the audience to spot the wrong thing in the picture. Spoiler, it's the cat on the shelf. So I thought I'd revisit that. Enterprise patterns and metadata services, and as Ben said, roll-up summaries then followed. But I'm delighted to find that a lot of these things, Apex patterns, are now taken on by the community. John Daniels and others are doing an amazing job at driving that on the open source repo. So Financial Force actually moved that over to public open source control. And declarative roll-up summaries is now part of the Salesforce.org Commons library, and there's an amazing team of UX, program management, and obviously developers driving the releases of that product. And I do stay close to that team, but I'm really proud of the efforts and focus that they're bringing to it. I did a lot with IoT back in the day and still dabble a lot with technologies. So I'm very fond of playing with robots at Dreamforce. That was a thing. The book happened, the blog happened, and really started digging into sort of a lot of APIs and Apex and some no-code stuff like Flow as well. And latterly, if you're at all interested, you might find me over in the retro computing land, doing things, learning amateur electronics and building things for ancient computers. But these are the things that make the world go round for us. So this is it's a little bit about where it all began and where it all is right now for me. Now let's get into kind of some of these questions. And the way that I'd approach this is break this deck down into 6 sections and ask ourselves some poignant questions. And the first one that you'll be surprised about isn't really about code. It's about understanding where you put your effort as a developer and how you qualify and validate that effort. So often we talk about if you've got a problem that you're looking for a solution for, or if you found a solution that you're looking for a problem, and kind of navigating whether that's a good or a bad thing. And a lot of us build code for many, many years, myself included, and really want to make sure in our businesses that we build that code for, want to ensure that code endures. So let's have some reflection about what type of code we really want to make sure endures and which ones we might tolerate some change in. And then really building applications and experiences once successful is a kind of new challenge of never ending feature requests and asks, can you do this? Can you do that? When will this be delivered? So it behooves us to think about how we can actually put the power back to those that are asking, if they have the skills to extend it, and what are the ways in which we can help them help themselves. And then testing is a big topic, and some of these topics, by the way, could probably deserve a full hour. So apologies if you find some of it a little brief, but hopefully it gives you a little taster into some things, and then some links I've provided to go deeper on. But testing is a broad topic, and we'll look at the triangle of testing and explore some of the types of testing and get a little bit deeper into unit testing as well for Apex. And then skills, being able to deploy your skills or those in your team efficiently and appropriately is ever more important these days. So we'll take a look at what type of skills you might have typically outside of Salesforce and where they can be applied within Salesforce. And I couldn't end the session without talking about APIs and some cool features of Apex and whatnot, as well as open source, of course. So with that kind of overview, let's dive into the first of our 6 topics. And the first one is like, why do we create solutions without problems? It happens. I personally have done a lot of that. I tend to just see some cool technology and some APIs and think, what could I do with that? And maybe I've got some problems, some business problems in my head, or maybe I haven't. But sometimes I'm just getting excited about the technology. So I'm reading the release notes and I don't necessarily have a cause in mind. I just, wow, that's good to cool. I've got to be able to do something cool with that. I'm not sure. So you just start playing around, and by accident, maybe you create something. It's a cool solution, but you're still not sure why you're building it. And sometimes we're in the middle of a project and we have a clear goal in mind, but perhaps we're finding ourselves over engineering, and we're thinking, well, some new requirements might come that our product team or our designers haven't thought of, but so I'm going to use this technology and build that. So sometimes we just find ourselves over engineering. And the other times, and this is, I'm lucky to be in this category, this case myself, that you hang around with people that can kind of get you in terms of a developer, understand kind of the way your mind works and solutions that you can build, and you create tools and frameworks and they connect them with problems for you. And that's kind of a really great moment to find somebody that can really partner with you and do that. But on the other hand, there are some pros and cons with that. So alternatively, why do we look for problems before we go off looking for solutions? Why do we do that? Well, generally, we want to make sure that we're spending our time appropriately and it's worthwhile. And we want to optimize that time on specific problems. And if we get really detailed in describing the problems, then we kind of avoid that over engineering or kind of being distracted throughout the delivery. So ultimately, it's about delivering faster and more directly to the customers and your users if you're focused on a particular problem domain. So what really is the answer here? Well, in general experience that I've had, being focused purely on problem domain can make you more comfortable in terms of you just solving the same, you're taking the same problems and solving them in the same sort of general way, the same technologies, the same APIs, the same tools. But without any experimentation, you can't have innovation. So you kind of need a little bit of both. So don't stop ever being curious. But if you find yourself going down a particular path, particularly if it's kind of a solution without a problem, stop and validate that as soon as you can, or take a risk. If you think that somebody will come forth and find a problem that matches this, then as long as the effort you're putting in isn't too wasteful, if nobody ever does, then take a risk. But either way, know what you're doing with your building without problem domains in mind is the general advice. But both are very valid things so long as you choose a time and a place to validate accordingly. So a little bit of a hypothetical conversation about kind of solution looking for a problem, because Salesforce is very wide in terms of what you can do with it, with no code and code and all of the different aspects of the Salesforce platform, the portfolio. So often it does behoove us to really think about the problem, because we can make some wrong decisions if we try and go solution driven first. But equally, because it's so wide, you need to experiment. You need to create that space for yourself to experiment and try things out. Otherwise, you will not innovate. So the second question here is, what part of your code should be around in 10 years' time? And we put a lot of effort into this code, and we accept that some code might change in terms of feature demands and so on and so forth. But generally, we're building a bedrock of an application that we want to endure, and our customers want to see that endure and be consistent as well, because they're making a big investment, or our users. So which really embodies the value of your application? What type of code are you writing that really says this is the kernel, this is the engine of the application? The rest is kind of how I interact with it, or maybe a certain set of features that are kind of on the ancillary. But what is the real aspects? Is it the UI that you're building? Is it the web or the mobile aspect of it? Is that the real killer piece of the code? Is it the code that governs the integrity of the data? A lot of trust is put into the data that your application represents. So, that really should be the code that stands the test of time, right? Perhaps. Or is it the code that provides all of the data access to the code, ins and out and read and write of the data that your code represents and your application maintains? Is it the code that actually does the automation, the things for us humans that we don't want to do, the calculations, the generation of things, the processes that it's automating? Is it that code? Or is it the code that kind of orchestrates it all? We often expend quite a bit of effort creating code that runs other code just so that we can do it in a certain time frame, or do it in a certain way that meets the user's requirements. But it's really just orchestration. So while we're thinking about that, what are the aspects of your code that are likely to change? What aspects are likely to change and evolve? Well, the user and consumer experience is very likely to change. Over the years, we've seen a lot of web stack changes. A lot of browsers have been standardized. Web and mobile are now AI with augmented AI. Apple are churning out all sorts of new experiences for consumers. So the tools and the experiences are rapidly changing all the time. And data storage to some degree can change as the scale that you're targeting needs. Sometimes you'll need a relational store. Sometimes you'll need a non-relational store, or other types of stores as things evolve. So these things feel a little fluid, and that's okay. These things change. So also the patterns that will orchestrate for scale, the way that you scale and the technologies that you can scale, those kind of patterns do change and ebb and flow. So given that change is inevitable, which are the things that you should really hope to retain and in the most? So hopefully you've been staring at 1, 2, 3, and 4 for a while, And I would posit that too is really important. The customers really, regardless of what UI you've built, what experience they're currently tolerating or not tolerating, or enjoying or not enjoying, the data is protected, because they know that you can innovate and change that. But if you're not looking after the integrity of the data, then you'll definitely start to lose some trust. And in terms of the data access, this is a little bit kind of 50-50 for me, but I put a tick against it. Ultimately, the data access that you're using is the thing that governs the security of your application, which is also very much in the hands of the trust of your users that they have on you. But it may change in terms of your data storage solutions, but there are ways to mitigate that. And ultimately, the business logic, I deliberately didn't use that term in this number 4, but the logic that is the business of your application, if it's doing asset management, if it's doing project management, if it's doing financials, it's all about how it does year-end processing, or calculates the orders from the quotes, or it does any kind of business processing that's irrelevant to the user experience, but literally core to what people buy and use your product for. So one of the patterns and approaches to thinking about this on Salesforce is to really think about where that logic lies. In this diagram, which many of you have perhaps seen in the past, and is these days not detailedly complete in terms of all the ways we can now invoke Apex, shows that you have the opportunity to scatter a lot of logic across your different Apex classes and the way that you write code, but you have an opportunity not to invest in putting that logic in places that are kind of more fragile. One day you might be using batch Apex, another day you might be using Cube, or one day you might be using Apex UI controllers, and some days you might be building a mobile app somewhere else using your REST APIs. But if you have all your logic in an Apex service, which frameworks and patterns aside is simply really logically and notionally just a class that you designate, and you can come up with coding conventions and policy for this that just has pure logic in it and isn't biased towards the way in which it's invoked. And yeah, you can then expose this logic through technologies and Apex REST to your web and mobile experiences. But all the while, it's all really governed by your Apex service layer, as the pattern is so named. And really then that interacts with other things as part of a contract. We create controllers that interact with the service class through the service boundary. We create domain classes that represent kind of the logic of each of your objects, because services really span many of your objects in theory. You might read and write from many things to create an order or work or quotes or calculate some financial information. So service is really an orchestrator of many objects coming together. But each object in its own right has its own behavior. What does it happen if I poke it to insert a record, or I go and update a record? The domain is really the part of the object that represents its behavior. And together they work really well. And the selector is really a place for all of your query logic. So surprise, surprise, this is kind of a process of separation of concerns, which allows you to really partition that logic. And when we look at how we want to create durability in our code, it's important, because if some of these things change, we're creating kind of a boundary between these layers that allows us to reason about what the impact's going to be, and even protect that code from impact that's happening all around it. So it's all in some ways about creating walls around some of these layers that help you protect and create enduring code. One of the things that's evolved a little bit since we started talking about code that exists around objects is triggers. We all know that there's many trigger libraries and frameworks out there that help us kind of move it out of the trigger class into an actual class. And that's not arguably these days a very new concept at all. And in some respects, the service layer uses that same logic in the race service here, which governs how a race is executed in a Formula One scenario. For example, you might actually interact with the contestants domain class when you're calculating points, but equally on the left-hand side, you might interact with the contestants domain class when you're servicing record inserts or updates, and likewise with the driver class. Now, one of the things that's explored a little bit more in the book is that that pattern can be split out, and we kind of can see that we might want trigger logic to be specific just to that particular class. So we have like a handler concept, and the rest of the logic that's more business logic for your contestant object goes to a contestants class. and the service uses that. So it's another level, another double click of separation of concerns, where arguably you're saying, look, this logic really just works inside the trigger, and we're going to put it in the handler. And then we're left with just the purest of object logic, which goes into the actual domain class. So an interesting approach to how you might double click down further into this and split things out. I just wanted to share with you. So this talk isn't about separation concerns. As I said, many of the topics we could go into a lot more detail on. So let's move swiftly on to number 3, now that we've looked at some sort of ways to separate your code, create more durability. And this is all about how you extend your application, because new feature demands can happen a lot, and you can either keep adding them to your backlog, or sometimes you just think to yourself, yeah, that's a very unique feature demand. Our product is about this breadth of capabilities and scope and target audience, but you've got a request that's coming in that's very domain or use case specific. It's kind of niche. So it behooves us to really think about, on the diagram here, your application is always available and running. The platform also has its APIs that expose parts of your application. But the kind of purple cog there is about your thoughts on how you go beyond that, because customers and users can access your data very easily with Salesforce. It's a very cruddy platform, create, update, and delete. So that's great. You've got a free data API for your application. But in terms of some of those services, the business logic that you've created, then it behooves you to think about how you might expose some of that. So if somebody isn't satisfied with your user experience, then they've got a layer that they can interact with and extend it in a different way. And who knows, maybe you'll adopt that experience at some point in the future. So think about ways beyond just the data APIs. Don't reinvent the data APIs either. I've seen some folks do that. There are some reasons why you might do that, but generally, if you're using best practices with your triggers and security and permission sets, then Salesforce APIs are a great data API for you. But then do expect that anyone will call those data APIs as well. Sometimes we think of our objects as nobody will ever interact with that object or go and insert some data. It's an open platform. It's an open database. So as much as you might document it, do expect anyone might poke your objects and go and insert and delete things. So code accordingly. But you can control that somewhat by shipping permission sets that govern exactly what you're expecting people to do with your objects. And consider building Apex REST APIs or Flow actions, we'll talk about that in a moment, or events to help people interact. Both of those latter two things are available without writing code, of course. So speaking of Apex actions, they've come a long way, really, since they first started. I was super excited then as a customer to see the advent of those things, a way of bridging the gap between no code and code. And now these days, you can create your own UI within Flow for an action. You don't just have to rely on the kind of prompt as you see actually on this screenshot. You can create a completely rich UI that allows Flow developers and Flow users to customize your action with your own set of user experience. And you can create common actions now because they can now take S-object and S-object collections. So you can make actions that empower admins even more with more broad access to the objects that they represent. So think about Apex actions, think about how you can customize the UI for those, think about generic actions as well. They're very powerful, obviously great responsibility with those, but also very powerful concept to create an action that can actually work against multiple objects. This diagram's taken from the use case in my book, but really it represents a flow of an event coming into the system. It's actually the race car emitting some telemetry into the event, but it's been exposed as an API via a platform event. So often we perhaps think of platform events as something we use as engineers just internally in the application, but the notion of actually just purely creating a platform event as an external interface to your application beyond just an API that they call is quite powerful, because you kind of get almost an async API directly into your application. Well, not almost, you literally do. So think of your API surface area not just as APIs that you build or the Salesforce data APIs, but as kind of async opportunities with platform events, which allows you to not only kind of allow information to flow in an asynchronous model, which is better for scale, but also saves you some time as well, because building asynchronous APIs is difficult to build from scratch. So let's move to number 4. How much are you investing in testing and what kind of testing? So let's face it, building tests is hard and it's expensive. And but on the other hand, hopefully, I think at any point in time, you're going to experience this. Some code goes out and there's some regression and it's big and it causes a lot of pain for your business and for your users and for your customers. So it will cause you to reflect on your testing strategy, and you'll no doubt go back and look at the cost of that. The reality is writing tests is really largely more than the actual code that you write. And a lot of people are kind of a bit shocked by that. If you get good at it, it can get closer to 1-to-1 maybe, but generally it's greater, especially if you're doing unit testing and you're doing a broader coverage, which you should be doing. It can take more. And if you get more advanced, you can be writing tests before you write code. Again, topic much deeper than this session right now, but really embracing the fact that testing is a key and large part of the delivery is really important here. But there are different degrees of testing and how much effort you should put into it and coverage wise. And the general test triangle here, and this isn't a new concept, I've adapted the labels here, but the testing triangle has us put UI integrations at the top. And these tend to span all of your kind of end-to-end processes that are the most critical. If you were building an invoicing app, it would be like how you enter the invoice, how you edit it, how you submit it, how you print it, and how it gets delivered to customers. You would probably build a UI use case and test that does all of that, because if any point in that journey breaks, you want to know straight away. Whereas if some of the things in that point do break, there may be workarounds, but always you wish to have UI integration tests or some form of wide sweeping user journey tests that allow you to really sniff out whether your application is truly broken and is just not working. The second level is kind of more at the service level. This is kind of what you would more classically look at in the Salesforce documentation. Things are evolving now in terms of more, as we'll get into in a moment, more deeper unit testing. But typically you'd create some test data in the Apex test, you'd do something, and then you'd use SOQL to query it. And arguably those are kind of a level of integration testing, because those services span many objects, they read and write from many objects, and they're testing some key business logic. And if you're using services as your API, then it's kind of testing your API as well. So service integration tests are important, and they're kind of usually headless by definition. There's no UI here. And maybe the UI uses multiple services. So you can see how the triangle starts to widen as you get towards the bottom. But it's really testing only isolated Apex tests, which is relatively new, but also quite hard to wrangle in our heads, but can dramatically improve the coverage of your code, not just now, but in the future. And I'll talk about that in a brief moment. Like, how can you write a test that helps you in the future? Well, obviously, you don't know what you're testing, but you kind of know when you build a class, that it's going to be used in certain ways, even if those ways are maybe not the most obvious ways right now. And it helps with execution time and also helps you cover more use cases. So needless to say, when you're doing integration testing, you don't really need a good separation of concerns, because you're just interacting with the UI, and it calls the controller, your service layer, it does some DML with your unit of work and queries stuff, and some of your trigger logic gets involved. And, you know, to some degree, that test doesn't care how you've laid out the code. In this diagram, I've clearly separated the concerns of the UI, the service, and the domain and selector. But an integration test is an integration test. When it comes to unit tests, it's really important that, because you're testing a discrete unit, a fragment of code, that you do have an idea of where that code is and where the boundaries reside. So as we talked about earlier, with a controller and a service and a domain class, if you separated those out, then you are able to actually target them for individual unit testing. So it's one of the hardest things in practice is unit testing, is testing only one class at a time. And that's the first thing that I discovered when I encountered this pattern. And I was grateful to have somebody who was a real practitioner in unit testing explain it to me. Because on one hand, I've got this UML diagram. I've got a car that I've built. I've got a car class. And needless to say, the car has a start and a stop and is running. And there's a dashboard class, and there's a display for the dashboard, and there's an engine. And of course, all of them are mixed together. They're all used. And when I look at my car class, it literally uses the dashboard and the engine that I wrote. So how can I just test the start method without having to do all the setup for the dashboard and all the setup for the engine? It feels kind of impossible, right? It's like, I get unit testing, but how can I separate these dependencies? Well, by modifying the car class and using the Apex stub API, we can actually fake the engine and the display, because all we want to assert is that the start method does what it's intended to do. So in this case, we've modified the car class to, so to speak, inject the dependencies. So the dashboard and the engine typically would come from the real classes, the actual dashboard and engine. But in some cases in our test scenarios, we're going to substitute them with fakes, because we don't really care at this moment in time when we write our test what the dashboard or the engine does. What we do care about is that the isRunning method returns something, and that is part of testing the car. And we also care that in this moment, the start method did call the initialize and it did call start. We don't care what initialize did or what start did, but we do care that start actually called those methods. And you might be wondering, why do we care about an implementation detail? Well, these fine nuances of how your code interacts between one another are effectively testing the behavior of it. And if that changes, depending on the test further upstream, you can miss that kind of impact. So it may be a positive or a negative impact if one day the start method stops calling the initialize on the dashboard. Maybe the dashboard's initialized somewhere else. But you should know about that when that happens and reason about if that's a good thing or not. So unit testing isn't just about asserting values. It's about asserting the code actually did what you thought it did at the time you wrote it. So anyway, there is a lot of details and information on this topic. And I'm pleased to see that the open source community has been doing an amazing job beyond the intervention of creation rather of Apex mocks, which is the kind of one of the original libraries from Financial Force and now also managed by the broader community. Apex Mockery, Apex Universal Mocker. So this is the first time I think I've introduced QR codes. These will just take you directly to things rather than you worrying about typing URLs and things in. So the stub API is the way that you actually do unit testing with Apex, and it's a Salesforce API, but it is pretty complicated. And Salesforce deliberately created it as an API rather than building their own mocking unit test framework, because there's a lot of innovation either in the industry in general. If you look at other languages like Java and Mockito, when they expected and predictably the community to create different flavors. So depending on how you want to approach unit testing, you've now got a lot of choices to libraries that can use. And each of these libraries comes with amazing blogs, amazing videos that describe these concepts and the value of unit testing in a lot more detail than I'm able to afford right now. So testing code in Lightning Web Components is also important. So I wanted briefly, before we left point 4, to move on, just talk about that. And the good news is that it does use a tried and tested framework. So if you have skills or desire to get skills in an industry standard tool that goes beyond Salesforce, then Jest is the chosen framework, and it integrates really well with Visual Studio Code. You can see all the tests that passed. And although this is obviously JavaScript, you can see there's fairly straightforward format and structure. It's code at the end of the day, but it's not kind of as scary as you might think, moving away from Apex tests to writing Jest tests. Setup side of it can be a little bit difficult, steep to climb, but once you actually got it set up and running, it's a really easy framework to use. So don't fear writing Lightning Web Component tests. There's a little bit of more work to do than, say, writing Apex tests initially, but once you get there, it's very rewarding for the same reasons Apex code testing is as well. And it is a form of unit testing at this stage because you're mocking responses from the client, from the server. So let's have a conversation about skills. I hinted there at the fact that you can use Jest, and it's an industry standard. If you're a web developer and coming to Salesforce, or you want to make sure your skills are going beyond Salesforce, then using Jest is a really good idea because it's applicable in Salesforce or non-Salesforce environment. But the reason why we're mainly here is because we enjoy creating solutions and writing code that delivers differentiated value to our customers rather than managing infrastructure. So how can you still use all of the broader skills that you've got while still staying within this kind of very reasonably comfort zone of letting Salesforce manage hosting all your code and security and uploading it and running it, and still yet use all of those industry skills? So the table I created here kind of looks across the top as the columns of all of those kind of industry skills, whether you're a web developer, a web component, or you're DBA, or somebody that knows SQL inside and out, or you're an architect, you're doing cache, or you're familiar with caching, or whether you're just a DevOps person that has been building loads of DevOps, or you just enjoy building tools. Well, this kind of grid shows you a few opportunities to stretch your muscles. So the first one that I think is a really one that often gets overlooked is that you can extend the CLI, the SFDX CLI. There's a SFDX CLI command that creates a template plugin for you, a Node.js project. And you can use your Node.js skills, ideally with Oaklef, which is an open source library. So build, if you don't like the CLIs of Salesforce, or there's some CLI or some automation you want that's kind of unique to you, then why not consider building a plugin and use your Node skills to do that? If you're a web developer, then of course we hopefully by all know that you can use your Node.js skills to build Lightning web components that sit inside, and it's based on web templates. So it's kind of, it's gone to the kind of aura days where it's kind of unique to Salesforce. This is a generally regarded web template technology available on other platforms and technologies. If you're a web developer and you just want to build a website, and we'll talk about that in a moment, then you can use the Heroku compute to host an actual persistent piece of compute with some endpoints on it that are essentially your web endpoints or APIs. If you desire, you can use LWR and LWC in that context as well, but of course other libraries are available. If you're an architect building microservices, then Heroku is also a good place for building headless async workers that are always running, listening to events and interacting directly via APIs or using PubSub. From a data point of view, if you're very familiar with SQL and you see some data that isn't really belonging in your org, maybe it's just part of a multi-org situation, or whether it's just literally data that belongs to an application or service that's not in Salesforce right now, then you can use Heroku Postgres to host that data and manage that data. And there's a number of ways to interact with Salesforce through that as well. And Heroku, Kafka, and Redis give you ways of managing your microservice desires. If you can use ways in which you can kind of sort of build that on Salesforce with Apex and services, kind of arguably that. I'm not going to start a kind of discussion about what a microservice is and isn't, but broadly, if you're interested in looking at that from an industry perspective, then eventing and Redis give you kind of caching mechanisms. Of course, functions allows you to use your Node and Java skills for compute only. So hopefully it kind of gives you a sense of kind of some of the skills that you might have outside of Salesforce and how you can kind of apply them here. Because the more you can do that, the more value you can bring to your business, and the more others you can bring in to help you as well. I hear a lot of people saying, I brought a web developer in to write myself a piece of Node code in my Lightning component or a CLI plugin, and because they know Node, and I kind of help them with the setup, but they just help doing that. So whether you have these skills or not, if you know somebody elsewhere in your organization, then consider whether they can actually easily come in and help. Now, I mentioned building websites and endpoints, and there's a QR code to the source code for this. This comes from the sample app in my book. The source code is available completely free. There's no need to purchase the book. Publisher probably won't thank me for saying that, but you can go and poke around in this web app that I built. It's built using LWC and LWR. And you can see that it's styled with SLDS, but it's running literally as a public website. You can log in and see your race results and things like that. But it also integrates with Salesforce data. And it's also using an API that was built using Node.js as well, using Open API, which we'll get to in a moment. It's just a really good way of being able to interact with the things that you build kind of outside of Salesforce or in Heroku, and host those APIs with Flow, because Flow understands the language of Open API. And frankly, most things on the internet do now as well. So if you're building any form of API, there's ways to do this with Apex REST APIs, though it's not actually out of the box supported, but think of creating an Open API schema for your API, and you'll make it much more broadly available to people to consume and understand your API. Now, there also is ways of exposing that to admins, as I hinted at earlier. So we do actually have a QR code service. Now, I just imported that with external services. Now, in my code, I just wrote a simple JS app. I'm using a few libraries. And then in my comments, there are other ways I've found of doing this, actually in code as well as just comments. But either way, I've got the descriptor of my API. And of course, it just goes off and uses my QR code library and takes the text and returns it. But I hosted that as an endpoint, and it was all kind of configured using the configuration here using Swagger, which is a library. But the point is I described it. I wrote it and I described it. And then what happened next is I pointed that descriptor to external services. And I was then just instantly able to use it in Flow. I didn't write any code. Maybe the admin was just given the URL and they used external services, and then they were able to create something. Now, the neat thing that's happening lately for developers, in case you're thinking, well, I want to use them from code still, is these dynamic Apex classes are occurring. So whenever you add an external service on the same page, you scroll down, you'll see these classes. And if you're familiar with like JSON to Apex or WSDL to Apex or whatever, these tools, this is kind of open API to Apex. It generates code and you can use it. It's not, if you kind of look at my descriptor here, you can see I've used certain operator IDs and certain names, and then it's inferred those in the Apex code. But it literally, the platform generated this code for me, and it doesn't appear in your org and conflict with the code that you've already built, which is why it's called a dynamic Apex class. You can see it and look at it. It won't necessarily be pulled or pushed or in your change sets, which I think is pretty cool. So whether you're a Flow developer or whether you're an Apex developer and you've got services that you're consuming or you want to build yourself, think about using Open API. It's super, super powerful for developers as well as admins if you do that. And unfortunately, the demo was broken today, otherwise I'd have shown you it. But yeah, you can then just display the QR code directly in there. And the admin just totally built that, having just been given the URL to the service. Next up is number 6 and the final one. And this is about where we get a little bit more geeky in terms of APIs in Apex and Salesforce. Not the ones that you can just use in your own apps, but also in open source as well. So very small feature, some of you might have missed it, but actually mainly to those building frameworks, having the ability to actually add errors and get errors and reason about them on an S object, which happened probably last year sometime, is really important if you're building shared logic to test across different objects. You're testing a field is blank or a field has a certain value in your S object. And sometimes we do create schemas where intentionally several of the objects have a lot of fields in common. So why shouldn't we be able to create a generic library that helps test those fields? Now, these methods on S objects help us do that. Now, of course, I kind of go beyond writing boilerplate code like that, and I think about, well, could I write a framework for that? So this isn't by any means a complete framework, but it's a kind of fluid API design. I kind of am a bit fan of fluid that allows you to express some basic test assertions that you want to do in a trigger. This isn't an Apex test. You could use an Apex test, I suppose, but this is just in your code. And the link on the QR code takes you to the blog, and it shows how it's kind of a lot smaller amount of code than all the if, then, else and case statements that you would normally write. So some of these things happen in Apex, and it's deliberately by the Apex PMs to enable us to do these things and create libraries, as well as kind of use them directly in our code. So think about that when you see these features. There's always an opportunity to create a wrapper around it and do something useful. I also want to call out messaging. I've been a long time fan of this, and to continue to take an opportunity to talk about it. Messaging to your users is probably the most important thing in the user experience, letting them know what's going on. And with these lines of code, if your experience in Lightning has been deployed via web or mobile devices, these show up literally as native messages on the mobile device. I was kind of a bit shocked when I saw it first pop up as a native iPhone notification. It's pretty powerful because I can't confess to understanding all of the ins and outs of making all of that mobile stuff work. Frankly, it's not an area I've delved into deeply. But it's pretty powerful to know that you've got this notification system at your hands, and you can target it for asynchronous processes as well to let people know what's going on, particularly with things that are happening in the background. And also Flow can use it as well. It's not just code. There's actual Flow action that emits custom messages, and they appear in the little bell icon at the top of right-hand corner of the screen if you're logged into the web browser, or, as I say, notifications on your mobile device. So do check out custom notifications. Very powerful feature for keeping either end users or admins informed. The next one I want to talk about, and Chris Peterson would not appreciate it if I didn't publicize and talk about user mode. And why would we talk about user mode? It's been available for a while to test security, but it's been a lot of work. And sometimes, I know, let's not hold the belief that we always add that code, because sometimes we just don't. Because of the circumstance or the context of the code running, it's an internal app, maybe we don't add it. But really, that's a slippery slope to security. And Salesforce has made it a lot easier now with these keywords. You can just put user mode on your SQL or use access level user mode in your DML operations. And it will basically honor the field permissions set up by your admins, which is important. Sometimes we don't control the permissions, but the admins do. And sometimes we control the permissions. I think that's personally, in combination with your admins, a better approach to create some permission sets. But using these keywords is dramatically less code. You can also use them with open source libraries as well. We've got a myriad of libraries that do trigger handling and DML managers and things like that. So there's an opportunity to enhance those libraries to know about these concepts, and we'll talk a little bit about that in a moment. But the big thing that I want to kind of cover here is that Apex runs in system mode, and you aren't forced to put these keywords on. But if you don't, then it just runs in system mode. And there's a big kind of convention generally at large in the industry, which is kind of run as least privileged, which runs the code with the least amount of access, because it forces you to think about the access you give rather than kind of think about that as an afterthought. And as much as it'd be great to just have user mode in Apex without any thinking, we're not quite there yet. And so these keywords are required. So you must be implicit about when it's used in your coding conventions or in libraries that you're using. It's really important to sit down as a development team and think about, when are we using these keywords, and also when are we not? What I mean by when are we not is, like, sometimes you want to have user mode implicit, either in your coding conventions or in a library that you're using. So it's just always there, it's there, and it forces you to create good permission sets. So in these cases, and this is unashamedly using fflib, but it could be any library, any DML library, DML manager. You're just creating a unit of work where you're going to create some register some records, and then commit that work. And nowhere in this code are we seeing user mode. It's just implicit in using the library, because the library defaults to that mode inside its code. When it does the DML, when it does the SOQL queries, it's adding that for you. So that's kind of one of the best things of kind of digitizing a coding standard, is to have a library that embodies that coding standard. You don't have to remember to add it. But you could equally not use libraries and just have it in your coding standards. Now, the other side of it is very interesting, and one that you might not have always thought about is, like, why would you ever use system mode? Like, when you look at that enum, it's got user mode and system mode, and you say to yourself, well, Apex does system mode by default. Why would I ever say that I'm doing something that's the default? Well, it's intentional in your design of your code. In some cases, if I'm creating a new contestant in my race, then I might want to validate what they've got a driver's license to be in the race. But that information about the driver isn't an object my users should not have access to. So then I elevate that access in my code deliberately and say, no, this code's going to run in system mode. And that's a really good practice to do, because you're being explicit and intentional when you are actually creating a heightened security, creating a wider access to data. And then people can see that and reason about it in code reviews and say, is that really necessary? What's more important for this also as well is you don't over permission. If you don't do any system mode and everything runs in user mode, everybody by default has access to everything. It's kind of an interesting thought. You might think, I'm just going to litter user mode on every bit of code that I write. Well, if you do that, then your admins are just going to go ticking boxes and admins and permission, or you're going to create permission sets that gives everything to everyone. So it kind of it really behooves you to think about user mode versus explicit system mode. So we'll move a little bit into talking about the book. These are some little shots I took because I have the collection of all four. I'm very, very proud to have the opportunity to work with some great forward writers, some great publisher in form of PAC-T, and also a number of reviewers throughout the years. And the bottom right-hand corner shows the new version of the book released a few months ago now. It's really about building applications with a lot of concerns that we've discussed today, but also it goes into UI, integration, some aspects of AI as well, and Salesforce reporting and analytics. So it's quite a breadth of things. And it does mention packaging on the cover there, because originally it did start being very biased towards ISV packaging. But as things have evolved, packaging is now available to customers and developers, not just App Exchange folks. So for the first time, the book does make the distinction in various places. If you're an ISV, this is of interest. If you're not, don't look at this bit. And if you're both, then you can read this bit. So feel like this book is both for ISVs as well as those building apps in-house as well, and that scale on the platform. It talks about some of those concepts of using languages outside of the platform as well, with Node and Node Java and other things. So if you have a background in developing inside other enterprise ecosystems, you will find it useful because it's kind of laid out in terms of how do I scale my queries, how do I scale my compute, how do I create separation concerns, some things that just transcend the Salesforce platform we've tried to overlay in this book, so you can use those kind of patterns and mindsets and find out how to apply them in Salesforce. So it talks about deploying packaged apps, whether it's for your business or App Exchange. It covers the enterprise app architecture patterns, such as the domain layer, unit of work, and so on. It's about 4 chapters of it. It talks about customizing your apps, very topic close to my heart in terms of how you enable others to customize your app, whether you're an ISV or an app dev internally. I think that helps them help us type thing in terms of doing things that we wouldn't normally invest our time in. And it teaches you how to go beyond Apex. You do have to have skills in Node and Java. It's not a book about programming in Node and Java. We talk about testing, highlights some aspects of testing UIs as well with UTAM. And it also gets into kind of that interaction between external objects and external services and connected apps that we saw a little bit of with the QR code example. If you create a service with the right interface, wonderful things happen on the Salesforce platform in terms of how you can utilize that service. So fair amount of coverage there. I do have a number of kind of chapters in each of the parts. There's 4 parts. There's now 18 chapters, I believe. So we decided to create 4 parts in the book. It is all 4 parts are in the book. So it covers publishing your app, especially if you're ISV, but mainly just creating the package if you're not. Leveraging features. The first thing that really is important, and it's something that took me a while to learn, is that don't code everything. Embrace the platform features. Be lazy to some respects about figuring out what you can use. Now, we all know this when that kind of goes too far in one direction, performance and other things can ensue. So it's got to be used in balance, but think about all the platform features. And some of the early design choices will influence what features can and can't be used. And then storage, there's a lot of cost with storage. There's a lot of kind of implications in scale and how you make those decisions and design of your schema. So this talks about that. And one of my favorite chapters actually to get into was chapter 4, which is just like, what happens when I send a request to the server? You know, what's the scope of it? What's the transactionality of that? Those things are really important to understand. These things cover, and you can pause the video because I won't talk about them in the interest of time, some of the new things that are in the 4th edition. And part 2, it gets really into the back end. As that's we start to build our way out of into the back end, then front end, then extension integration. And we talk about the separation of concerns, building service layer. And this chapter 8 is brand new. That talks about using other languages and programming tools other than Apex. So again, pause momentarily. You can take a pause of that later. Developing the front end is part 3. This goes into kind of LWC's kind of approach to separation of concerns, talks about how you create interfaces and eventing between LWCs, how you connect them to your backend logic. Another amazing feature of Lightning Experience and Salesforce for Mobile is how you can embed things in it. You don't have to build the whole thing yourself, but there's so many places now that I would imagine wouldn't even fit on one slide unless it was tiny font, of where you can put Lightning components and where you can embed Apex actions. So really understanding that is is the key aspect of chapter 10, is how you can expand the Lightning experience. And then the last chapter, the last part, gets into kind of some of the nitty-gritty around scale and extensibility, unit testing, as we talked about earlier, source control, and integrating with third parties, and a little bit at the end there on AI. So once again, I'll pause just enough for you, anybody watching the video, to pause and check those new features out for 4th edition. And just finally want to say thank you to all of those that helped review. I won't cover everybody's names here, but thank you. A deep gratitude for those that help review the book, give great feedback, really drive the direction of it, and the past reviewers as well. It's in its 4th edition, and we've had many people come and go and help on the book. And then finally, the community. I do this really to help the community share knowledge that I've acquired over the years, and keep this book as up to date as we possibly can. So thank you. And with that, I think we might have like 4 minutes or so for questions, Ben.
Hey, Andy. Thanks so much for that. You must be exhausted. There was so much great content in there.
Yeah, no worries. Apologies if I went a bit quick or a bit too not deep enough there. I think it's perhaps one of my traits where I try and cram too much into a session, but happy to take more questions async as well from folks on LinkedIn if we don't get through questions. So anyway, what have we got, Ben?
Yeah, cool. Let's do it. So I've got a few questions down here. If you've got any more, feel free to drop them in, and we'll try and get through as many as we can in the next few minutes. A nice easy one that I can answer is, it's going to be recorded. Yes, it will be on our YouTube channel afterwards. So feel free to go over to there, subscribe, and then you'll also get access to this webinar afterwards. So we do have one question here from Ibu. I hope I pronounced that right. What is the difference between Lightning Web Components and LWR, which I actually don't know the acronym for, so you might need to help me, Andy.
Yeah, sure. So Lightning Web Components, correct. LWR is Lightning Web Runtime. So basically, when you write a component, traditionally in SFDX, and deploy it and use it in Lightning Experience, you're just doing the component bit, the bit that sits in the page, but everything else that runs the page and brings the page up and loads the components and reloads the components is actually the runtime of Lightning. And Lightning Experience is an example of that. Lightning Salesforce Mobile is an example of LWR. But if you're building your own website, then you can take basically all of that runtime that Salesforce is using and run it over in another platform such as Heroku. So it's basically the framework, the kind of engine that composes your application and your components together and provides other services to your components. So it's kind of what you've experienced in the background today if you've just largely been creating components in Lightning Experience. But if you want to move out of that environment into a more custom website experience, then you'll need LWR. Not necessarily always need LWR if they're static Lightning Web Components. You can just host them on any website. That's also possible, to put your components just with some modifications onto the website statically, and have the code call some endpoints. But if you're actually wanting to create a composed application and get some of the benefits that you experience in Lightning Experience, then you're going to need something like LWR to spring it into life.
Nice. Thanks so much, Andy. And probably just time for one more question, actually, because we're nearly at the hour. But what are your favorite online resources to learn Salesforce development and keep up with everything new and latest and greatest?
I'm a feeling that was a question from Salesforce Ben, and he's telling me to say Salesforce Ben. But quite honestly, I do tend to just go a lot to the release notes. It sounds a bit also contrived that I would say that, but I do go through those. I also have been known to just compare the WSDLs and things like that, to compare the raw materials. It's just the way I learn. I like to get in the nitty-gritty and then work my way out. But yeah, there's obviously a number of blogs from our MVP community and such like that are definitely worth following.
Yeah, definitely. So much going on at the moment, especially with AI. There's a lot to keep up with.
Yeah.
Great. Well, yeah, I think we should wrap up now just before we go past the hour. So thank you so much, Andy, for this presentation. It was super, super interesting. There was already some people coming in, Chi, saying Andy's book is still his #1 recommendation. So there you go, straight from the audience. So check out Andy's book, and thank you everyone for attending as well. This session was super popular, so thank you for spending your time with us today. Any final words, Andy?
Thanks for listening. Please feel free to drop any questions in LinkedIn on the thread that Ben's got here. But otherwise, have a great day and go build some amazing apps.
Great. Thanks a lot, everyone. See you soon.